going to do some hydration reactions. We're going to look at these products. In this case, it just says draw the organic product. Sometimes you will end up with a minor product and a major product. And this one, since they didn't ask for the minor, we're just going to focus on the major product. We're going to be adding HOH, so water is just HOH. Across this double bond, these are alkenes again. We're going to add an H and an OH. So we're going to break this double bond. One of these this carbon and this carbon, one of them is going to get a hydrogen, one's going to get an OH. In this case, it doesn't matter which one goes where because it's a symmetrical molecule. But for these other two, it will matter who gets the H and who gets the OH. It depends on how many hydrogens are attached to each carbon. So in this case, you can see this carbon has, if we're to draw this out, this carbon has a bond to this CH3 group over here. It's got a hydrogen, and then it has a double bond to this carbon. That carbon has a hydrogen and another CH3. I'm going to draw out those. So we're going to be focusing on this double bond in here. So you can see they both have one hydrogen attached to it. So it doesn't matter which hydrogen I add, which carbon gets the hydrogen or which one gets the hydroxide. So when I go over here on this side, I'm going to have my CH3 onto this carbon. I'm going to draw it with a double bond. I'm just going to re-copy this picture over here as my product, and then I'm going to change it when I break that double bond. So I'm going to break one of these bonds, just that one, break a bond. I'm going to add an H on this side and an OH over here. And so that's going to be my product, my final product. I have an alcohol. So I've got 1, 2, 3, 4 carbons, and this one, the OH group, is on that second carbon. If I did it the other way, if I added an OH here and an H there, we can see it's going to be the same structure. I have an OH over here and an H here, because when I would start naming this, start numbering the chain, I want to number closest to the alkyl groups. That's my longest carbon chain, even though we haven't named alcohols yet. You guys kind of get the feel for how we do these things. We want the smallest set of numbers, so they're going to be the same. So I only get one product in that case because it's a symmetrical molecule. Now down here, I've got a different situation. I've got a double bond here. This carbon is going to have 2 hydrogens, and this carbon has, what, 1, 2, 3, it's going to have 1 hydrogen. So they have a difference in the number of hydrogens. I don't have to worry about these because they're not involved in that carbon chain. I know that I have 2 here and I've got 3 here. That's fine. If you want to take that structural formula and write it out in a condensed form, you can do that, or draw the expanded form here. You can do that. This carbon is going to have 2 hydrogens, right? This is what that means. He's got 2 hydrogens and a double bond. And then this carbon here had 1, 2, 3. So he only has 1 hydrogen because he's got 3 other bonds. This is a CH2 and a CH3. So if it helps you to take this structure and draw it out to figure out how many hydrogens everybody has, great, do that. Water, again, is HOH. Now I can look at this carbon and say this one has 2 hydrogens, this one only has 1, which means whoever has the most hydrogens is going to get more hydrogens. Whoever is rich in hydrogens is going to get richer. The rich get richer. So that hydrogen is going to go on that carbon, and this hydroxide is going to go on that carbon. So I'm just adding H and OH across that bond. If I were to draw this out again, I've got my 2 hydrogens, I've got a double bond to this carbon, got a hydrogen down there, and then I don't really care what's over here. We've got a CH2 and a CH3. But just to check, this carbon has 1, 2, 3, 4 bonds. This carbon has 1, 2, 3, 4 bonds. Those guys are fine. So now what I'm going to do is I'm going to break this bond here, break that bond, and I'm going to add H and OH. So to this carbon, since he already has 2 hydrogens, he gets the H, and this carbon is going to get the OH. And it doesn't matter where you draw them in space, just that this carbon now has an OH and this one has an H. I could have done it the other way. This is what we call our major product. This is our major product. The minor product would have been if we flipped it around. So if we did C, C, CH2, CH3, if I put the OH over here and the H on that side, this would be the minor product, minor. I want you to kind of focus on the major and use that Markovnikov's addition. Now, both of them are right. I mean, together they're right, but you definitely want to indicate, if you're going to write both, then make sure that you show which one's the major one. And the major one is when the hydrogen attaches to the carbon that already has the more hydrogen. Now, if we look at this one, interring structures always confuses people too, just because, like, how many carbons, who has all the carbons, how many hydrogens do we have? This carbon here has 1, 2, 3, 4 bonds already, so he doesn't have any hydrogens. And this carbon has 1, 2, 3 bonds, so he's got a 1 secret hydrogen over there. So when I'm looking at adding H and OH, the H is going to go to the carbon that already has a hydrogen attached to it. So that guy, this is going to be our major product. And that one's going to go on that carbon. So again, just adding H and OH to the carbons in the double bond. So when I go back over here, add my structure. I had a double bond, and I have 1 hydrogen over there. Secret hydrogens, hidden hydrogens. We don't usually draw those out. So I'm going to eliminate my double bond, and to this carbon, I'll add the H, and this one gets the OH. That's going to be my major product. My minor one, the minor product, would be if I put the OH on this side. Right, so I'm gonna have, this is the one that dominates. You can also, if you don't want to put those hydrogens in there, you don't have to show where they go because they are usually not drawn out in the skeletal structure.